Okay, what we have right here, we're going to talk about trig limits. All right, and these are the second tutorial. We're going to talk about some more difficult trig limits besides the basic ones. Trig limits that you should know. If you want to find one of the basic trig limits that is derived is when you find the limit of sine of x over x as x approaches 0. Normally, this is not continuous. There's a hole here at 0. How do we know that? Well, right here, as you plug in 0, sine of 0 is 0 over 0, which is usually means it's removable as continuity. All right. We can go then to our calculator and look at some of these values. And let me take this, and we have, for example, sine of x divided by x, and we graph this. We can see that as we graph it, our value is approaching 1. Okay, it's approaching 1. And we can see from the right and left side that value, that limit is approaching 1. So graphically, we just have determined that this limit, all right, though it is removable and though it is undefined, does have a limit of 1. Does have a limit of 1. We can do the same thing for this other trig limit of 1 of this. Okay, 1 minus cosine of x over x. If you took, as you plug this in here, and obviously I paused it and got a little bit farther ahead, you graph this one, and you can see that it does not, oh, it looks like it's going to negative 1, but actually it is approaching 0. 0. Once again, this is undefined because as you plug in 1, we get 0 over 0 again. If you trace this and you actually plugged in 0 into our function, all right, what you got is no value. Okay, there's a hole, but yet the limit does exist. The limit is approaching 0. Okay, we're going to use these two limits, and you want to write these down. You want to know these, okay, because we're going to use those to solve some basic, more advanced trig problems using the property of limits. In these, the first one we have is example number 1. Let's say we have the limit as x approaches 0 of sine of x over 3x. Using the properties, we can see that 1 over 3, okay, we can factor that out. Now we have sine of x over x. One of the key things is when we have this, we go through, we realize that this is going to be 0 over 0 when we plug it in. But using what we know about sine of x over x from our previous example, we know that 1/3 times, well, we know this limit, though it is a hole and it's undefined for the actual value, the limit does approach 1 for this particular function, and therefore our answer is going to be 1/3. Okay? Doing the same thing when we have a limit of x and secant of x. Plug in pi. Okay, well, as we plug in pi, we give pi, and we have secant of pi. Well, secant of pi, well, it appears that actually we can use direct substitution. It doesn't give us 0 over 0. All right, it actually does give us a value. So that's pretty cool, because 1 over cosine of pi, pi again is right over here, has a value of -1, 0. And cosine is x, so it'll be -1. So this is going to equal -1 times pi, which would then give us negative pi, would be our answer. Well, let's try to get some more difficult ones. All right, keep on moving through. Okay, let's say we have these two. Okay, these two. We have sine of 3x, and then we have 2x. Well, this is a little bit more complex. One thing that you realize is that, well, we have sine of 3x and we have x, very similar to what we had right above it. So we're going to try to do the same thing. So we have 1/2. We have sine of 3x over x. But this is different than this one right here, because we have this 3. In order to get rid of this 3, well, we can't really get it. We can't factor it out. That's illegal. But what we can do is we know another little property about the sine function. If you have, I'm going to just erase this. If you have a limit as x approaches 0 of a sine of some sort of value nx and then nx. So this constant, these values are the same. This limit will approach 1. This limit will approach 1. Well, using that knowledge and knowing that if we know that the inside and the denominator both are the same. That's going to be approaching 1. What we need then is we need a 3 here. Well, we can't just place a 3 right there. That's illegal. But what we can do is do a little math magic where we take that 3 or multiply this function by 1, 3 over 3. Now, by multiplying 3 over 3, I can now borrow that 3, or just shift it over, all right, and use our properties. We know that 1/2 stays 1/2, it's a constant. We know that now 3 as a limit, as x approaches 0, of sine of 3x over 3x is now going to be approaching 1, and then we have this 3 left over. So our actual limit is going to equal 3/2. 3/2. One little trick in order to solve these problems, it's not mathematically sound, but your limit of sine of x over, or whenever you have these values, our limit is always going to be those values right there, 3/2, because when we do our algebra, it always works out that way. But not mathematically sound, but it is a little trick. Now, we also now have another one, similar to the other one we had just above it, x sine of x. Well, once again, we have pi, a little bit different. We plug in pi, and we put in cosecant of pi. All right. Well, cosecant is actually reciprocal, so I'm going to actually change this up. We have pi, and this actually would then be over sine of pi. So that would actually be sine pi right there. Oh, okay. Well, pi is pi. Sine of pi, if you look at it right here, sine is y, which would be our 0. So we actually have pi times 0. So we use direct substitution for that one, and we got our answer. All right. Well, let's try these two to finish up using those. Okay. Well, now we have sine of theta. Theta is just like the x value. And we have cosine of 1 minus cosine theta. Then we have this 2 theta squared. Well, normally when you look at that, what I usually do is I take whatever the constants are and take them out and just see what we have. And now it's like a game. It's a little puzzle. If you recall and you remember all the different trig functions we talked about at the beginning of this tutorial, is that this right here, when we plug in 0, sine of 0 is 0. So we have 0 over 0, okay, undefined. So there's a hole. So we're going to do a little simplification. Let's see, oops, trying to do there, squared. Let's see if we can separate this into limits we know. Well, if you recall, the past one, we know that sine of theta, or x over x, that limit equals 1. Well, what I'm going to do is I'm going to borrow one of these thetas, and I'm going to put it right underneath that. So now I just have an extra theta. Well, then this extra theta right here, I'm going to take that one and put it underneath the 1 minus cosine of theta. Well, if you recall then, what we have are actually 3 different functions. We have the 1/2, we have sine of theta over theta, sorry, I put x there, and now we have 1 minus cosine theta over theta. Well, 1/2 is 1/2 when you take the limit as theta goes to 0. Sine of theta over theta we've been doing before is equal 1, but if you recall, in our other one, the last one we did in our 2 important ones is that 1 minus cosine theta over theta is actually approaching 0. So now we have 1/2 times 1 times 0, which equals 0. Once we have a little donut, put some glaze and sprinkles on there, and we're good to go. A little bit more complex, but using properties and limits that we know, all right, we can separate that and solve. The final one, we have tangent squared of x over x. Tangent squared of x over x. Plug in 0. Well, tangent of 0 is 0 over 0. So once again, we got to remove this continuity, got a hole here, and we need to solve this. Well, tangent, whenever you're doing with trig, we're going to separate this and put into sine and cosine. So tangent is actually sine squared of x over cosine squared of x. And then what we have right here is we have, I'm going to just separate this out, we have times 1 over x. So I'm just rewriting this into a more easily used statement. Well, this is where sometimes students get a little confused and like, well, what do we do? Well, How I look at it is that I'm a problem solver. I'm trying to see, okay, can I separate this, use a little algebra to help me find values that we know. And recall in our previous one that this sine of theta over theta is, we know that limit as x goes to 0. Well, in this case, so if I can take one of these sines, I have one sine of x because it's sine squared, and I do have over x, I'm going to separate that out. Because I know that limit as x approaches 0, that equals 1. What I have left over then is sine of x over cosine of x, which actually is just tangent. Well, what is tangent? Well, as x goes to 0, this is a continuous function. So this is actually going to equal 0, because tangent of 0 is 0. Well, 1 times 0 is 0, and that is our answer. So we went through 6 different limits, more difficult, using both direct substitution and using these 2 main trig limits that you should know, love, and be very familiar with. I hope this helps you out with some of your future trig problems, especially when it deals with calculus and limits. Good luck and God bless.